So what we were talking about today, we have two things. One is the RAG. I think I need to get a quick walkthrough with this one so we can understand why we wanted to architecture the application structure like what we were talking later in today's things. So we will cover two things today. One is the RAG, which is like when people talking about the like AI application, what they actually means. Most of the people what they actually means today. And then this will give the idea why we have the architecture of the application in the way we have data pipeline and the backend. So this will be what it in today. So the RAG part actually is very simple. We just have the RAG itself contains 3 words. I think most of the people probably already familiar with, just in case some people don't. So it have the retrieval, argument, and the generation. So what we will discuss what these 3 concepts is and have some discussion. And in the end, these 2 demo, we want to demo it, but each of the demo only have 200 line of the code, and we have published the codes online, so you can download it and directly run it to understand what we mean there. So the introduction, like what is RAG? It's basically use the large language model to answer the question more in context by integrating the relevant private data source. So generally, if you open your chatbot or the like ChatGPT and you ask a question and you put your personal information about, for example, you say, you tell it your mom's name is what, and you ask him what's your mom's name, then this can be a RAG. So the RAG first is need to retrieve your mom's name, and then you put it in the chatbot with this like a retrieve the information and your question. Then it will generate a response for it. So this is kind of the simple version of the RAG. So, but the retrieval, the question of the retrieval is where we retrieval from. For now, most dominating of the kind of application or the research, I actually retrieve it from the unstructured data, which are the PDF files or the HTMLs. That's what the people are excited about. That's also what our research area was currently like focusing on, because the exciting part of this is the whole world, 80% of the data actually is lived in the unstructured way. But that doesn't mean you must retrieve from the PDF files or must retrieve from the HTML files or the immersed text sources, unstructured data sources. You still can retrieve it from the relational database. So you can see here, like this is a demonstration about, so in the past 10 years, what's the whole world most popular database. You can see it from here, the relational database still holds 86% of the shareholders. But this whole calculation here doesn't include the unstructured data. So why the whole world excited about is still valid, but what I'm trying to deliver here is don't limit your mind just to retrieve the information from the unstructured data. You still need to think about the structured data. And you can see the trending here, the graph DBMS. The graph DBMS is attracting so many attentions in the recent years. I can say in the next year there will be another spike, because the graph RAG can be seen like an even better way to help the large language model understand the complex structure of the world. So this is just so this one here is just trying to open your mind, like the retrieval. Don't restrict yourself into the unstructured data. You can do more things than that. And so that's basically the explanation. So actually, structured data is easier to start with. So when we're trying to get you guys think about what's the project that you're trying to deliver in this first step bootcamp, I think what I mentioned two directions. One direction is you access datasets and the websites from the government. They have a lot of the laws, official rules. You can get that data downloaded and do it in the unstructured database, process it. But you also can do is there are so many open source database online. So that's the kind of the database you actually can construct it into a local database, and then you use text to SQL. You have an NLP question, you construct a SQL query and retrieve the information from the database, and put the retrieved information into the prompt, and then you can do the generation. Sorry, I think I forgot to record the section. I will start the recording. And so basically, another will be normally kind of being ignored part of the retrieval is a third-party API. For example, if you want to get your RAG is pretty performance, you actually just use the Google Search API, and it can actually retrieve a lot of useful information in your application. So when you're trying to I think you're already starting to thinking about your applications and your projects. But when you think about the data sources, you don't really need to restrict it to a limited area. You can think about these over 3 different sources. And then how to do the retrieval. The typical workflow and the most popular currently, a lot of people was trying to do the research on is this workflow. So basically you have 2 stages. One stage is you have the question. The question was coming, and you basically can, as I said, you can get it into the text to SQL large language model. You can ask the GPT generate a SQL query for you, and you can query the database and get the result, get the large language model to do the generation. Or you can have a lot of purposely build text to SQL models. That's a research area. If anyone interested, you can start researching that area. It's not yet perfect, but you can also kind of construct the SQL queries and retrieve it from the database, augment your prompt, and generate the response. And for the unstructured data side, you basically what you're doing is you have a question, you come in. The original, when you're trying to search on the government website, they actually is a keyword-based search or some index-based search. That way still valid. You don't totally need to be the vector-based search. You can steer to the loaded a keyword-based search from the text sources, and then you get the text out and get the prompt being augmented with this text. But in the red square part is actually the refined part the whole world was working on. So the question will first be embedded by embedding model, and then your whole documents here will also be embedded by embedding model. So you will compare your vector together inside your vector databases, other sources embedding, and you retrieve the similarities documents and put it in the prompt. So you can see the name chain and the number index, both of them actually focusing on this part. When I was make this kind of slides is 2 months ago. The name chain and the number index actually is focused here, but recently, actually, that's how the AI area or the AI engineering area changing speed. Currently, number index already changing their direction. They're basically starting to treat them as a large language model data processing platform rather than a tool like the NanChain. But NanChain still is in the direction says they just get your question in and they do a lot of pipeline process into the stage you can retrieve it and do the generation to play the tricks. So I think we will keep updating this and trying to see what will happen. But this is typical workflows, the whole picture of the retrieval and RAG. It's not just this red square part. And I think one question was popped up is what's a vector search? So I think that's a new concept that comes in or new word coming. But eventually, it's very simple one. So your original source of the files, for example, PDF files or other files, the sources will be split into the chunks, and you have an embedding model. The embedding model will take the text or the chunks of the text as input and get them into the vectors of that chunks and put it into the vector spaces. So it's a high-dimensional vector. It will be in the embedding spaces somewhere. Your questions will come in embedded by the same embedding model, and then your question vector, like the red dot here, will be also put into the vector spaces. Then you will trying to find out their nearby nodes, nearby vectors. You are trying to find their top 3. Then these top 3 will map into the original chunks you have split it. And then this one will retrieve as a context. So this is expanding what happened here in the real vector. In this one, why people excited is because original days you are doing the keyword search. But when you're trying to talk about something about the king, actually the queen is similar as the king. However, the traditional none of the way here can get them being connected and retrieved together. This vector search way can get them to do it in this way. So that's the exciting part. But as we see here, there is one question, then even like deeper and popped up is how we do the split into the chunks. There are a lot of ways. That's actually the part I think the whole industry not ready, and that's the reason why the RAG not yet ready for most of the application areas. There are typically these several different ways to do the split. So you give a sentence or you give the whole document. You can break the text down by the periods or the new lines into different sentences, then you embed in each sentence. This is one way. Or you can kind of using it by like if you have probably a table or some like specific documents, you can get it being split by a specific symbol or by specific words. You can also do something like that. Or you can customize it like a document. You can chunk it by each section. That's another way, but you need to bit more effort in the rules when you're trying to process the data. These other strategies was currently being documented in actually the NanChain and the mostly adopted ways to do the text splitting. But you can see the problem here is, for example, we have a very tricky like a document. Someone when he is writing the like papers, he actually repeated 100 times, say, like, I like to learn computer science, I like to learn computer science. And if you come back and you're trying to retrieve the top 3 relevant content about the computer science, then all of your retrieved content actually is these 3. You don't really have other content about, for example, I think computer science design of the material is bad. This content will be totally hide because you only retrieve the first 3. So like if we can put this 100 repeatable I love computer science text actually into one chunk, then your diversity of retrieved content can be richer. However, this is something like you harder to be balanced by the current research, even research in the industry. That's something you will feel a bit struggle with when you're trying to really build a project and have some advancement there. So, and then is about the multimodality data. That's very cutting edge. Like you probably have the audio, video, images, and for example, in the documents, you will have figures, you will have tables. And you wanted to, when you have asked the question, you also want to get back all the figures and tables related to your question. But it will be hard, right? Because how could you get all different modality of the sources be aligned together? That's actually a research direction. But there are several ways you can already do that because you have the models to convert your audio to the text. You also have the models to understand your figures or understand your videos. So you can use some models to unify them into the text first and then do the retrieval to see what the performance will be first if your application is pretty cutting edge. Otherwise, you have a lot of models directly converted into the embedding models. So after that, we can see, we know how we do the data processing now. Even we don't really have a perfect answer. And the next question is, what is the embedding model? Embedding model is something you just input the text or any data resources. They're trying to get a similarity. You first define the similarity. Normally what they define is kind of semantic similarity. You get the similar content being close together in the embedding spaces. So their vector will be close together. But for the two things, their meaningful is totally different. You want them also in the embedding spaces is totally not close to each other. That's basically what the embedding model in a simple explanation. And you have hundreds or probably thousands of the embedding models nowadays in the Hugging phase. So there are actually two options for the embedding models. First is using the open source one. Another is using the API side, the OpenAI provided embedding models also. And which one to choose? To be honest, I don't have answer. I don't really think anyone have a very clear answer, or there is a clear win in this area. But you at least can go to this benchmark and choose a proper model to start with, or just use the OpenAI's model to start with. But OpenAI's model is paid version. Even the cost is very low, but still paid version, and you have the possibility to leak your data to the like OpenAI or third party one. Even they said they wanted like use your data to do anything else. But if there is security concerns or privacy concerns, even if especially in the medical area, then you definitely go to the open source one rather than the like OpenAI's one. So there are some typical models you can choose. Like the BERT is very old and classic one, and it's a small one can probably run on any computer. You can use this one to start with. OpenAI have provided this one is a small, one is large embedding models you can try. NVIDIA will provide this pretty good one. Currently, I think they kind of win that benchmark. So you can try these three based on which one you want. And then the next question is, I have the embedding, where I store it? Like storage actually is not the problem. You can store it in the plain text. The problem is when you're trying to retrieve it back, if you want to deliver application to the end user, your latency is a big problem. You don't want it to, the end user will wait 10 minutes or 20 minutes until you get the retrieve the information back. So the challenge here is after you store the vectors, it's normally 1,000 dimension or more of the vectors, and you will have a lot of them. But if you have a text as probably 20 MB, and you're trying to embed them with a very, very large embedding model, you probably will get your embedding of your, like the embedding of the vectors, the size when you save that the text will go to gigabyte, which means your data actually explode. Then when you're trying to retrieve the data back, you need to calculate against each of the embedding with your questions embedding, which is a very, very like a time-consuming calculation. So you need to get them parallelized. So you need to have some database designed for this specific purpose, which is doing the similarity retrieval for the vectors, especially high-dimensional vectors. To get them, the retrieval speed is very fast. Luckily, we have some people actually working in this direction. There is not yet any perfect solution, but with the help of this database area people and like cloud engineering people, you have this kind of database. So a naive solution of the vector database is you store it as a CSV file, you read the files into the memory when you're trying to search it. You compare your question vectors with each record and get the top K result. Eventually, in the vector database, it's doing the same thing, just that they will optimize the whole strategy, how they retrieve the similarity content back. So, like our solution just mentioned, I said it's naive, so we don't really have like any optimization of this embedding model. So the next thing is like how can we improve it? And do we have a winner for this kind of like vector databases? The answer for me is no, we don't have like a solution or best practice for which vector database you should choose. You should still be alerted online about which one will be the best one next. But we have to do the comparison at the current stage. There are several of them actually show some promising, like a winning status. So the first one is called content. This one is what we will use in our full stack architecture. So this one I have tested out is open source and you can host it anywhere. And the retrieve speed is quite good. The retrieve accuracy is also quite good. Another open source option you can turn to is a ChromaDB. This one is similar architecture as this. In the background, the backbone of it is still SQLite. But both of them was designed in like a similar way, but they probably think they will win this like a game. This is a specific one. You can see this is actually a closed source one. It's like the OpenAI in this kind of vector database domain. This one, they actually handle the harder part for you, which is infrastructure. So if you have a very large database of the vector database and you want to store your data somewhere and retrieve it very quick, and you have, for example, if you are the BHP or the Rio Tinto, you have tons of the unstructured data, then your vector database will be extremely large. Then you need to have a dedicated team there to do the scale up of the whole database and get them to return the things fast enough, which is, I think, which will be eventually will be one of the teams later, like a job title on the the seat. But nowadays you haven't seen that because the RAG is not yet ready. But this is kind of going to the OpenAI's direction. For our one, we definitely will use this one, and they have very good extensive documentations you can explore first with this. And then it's the argument. So what's the argument? It's basically it's a very fancy word, but in the end of the day, it's too simple. So this is one of the templates. People call it prompt engineering. What the prompt engineering will do is basically ask the question in a specific way. So in this prompt, prompt engineering is basically you have the user query, you have your retrieve the context, and then you ask it to answer the question based on the information you provided. Then in the prompt engineering, you have specific strategies. For example, you have the fear shot learning or the chain of thought. The two words also sounds very fancy, but eventually it's also very, very simple. The fear shot learning is basically what it's doing is I think I have a fear shot learning example. Yeah, this is the fear shot learning example. So basically, if you ask a question to the large language model, say generate a SQL query for me, and this one is pretty specific, complex one. The large language model cannot handle it easily. You can give it a similar examples or several similar examples, and then it will follow what you have done and give the response to you. So this called fear shot learning or one-shot learning. And chain of thought is basically when you're trying to tutor a student or tell your son or your kids you need to do this first, and then do that. That's basically chain of thought. You in the prompt you give a chain of thought prompt say you need to do this first, you need to do that and do that. So it will follow the simple smaller steps pretty great and then generate the results in a good way. So that's just the different ways to do the prompt. You can try to search online. There is a lot of people trying to publish in the GitHub about the state of art or how other people do the prompt in a good way. But my observation actually is contrast to this. I find out if the large language model is smart enough, you actually don't really need to tweak too much with your prompt. It can already done very good things. So it's something like if you already experienced enough, then some junior people come to you with a very complex question. He just named a few words. You can understand what he is doing. I think the same thing happened here for the large language model. Then the last step is the generation. Generation is the simple part for us because it's a large language model doing hardware. But here in the the domain, you actually have two types of the large language model. The first one is something like the GPT or the Cloudy. I think I still recommend everyone to use the Cloudy. I think it's much better than GPT, especially in our domain. But they are closed source. You need to put your data to them. So they will access your data no matter how they promise you. So that will give us a bit of concern, especially in the health area or the security area. In the health area, it's totally restricted. You cannot share your patient data with anyone else. So in this way, people will turn to another one, which is starting from the Meta. They publish the Llama. People tend to call it a public, open source large language model, but in theory, it's not accurate. In the whole market, there is none of the large language models is open source. We only have the public available open, large language models. Because to reach the status of the open source, you need the architecture to be open source. You need the data source to be open source. And also you need the weight of the model to be open source. Most of the models public available is just the weight and the architecture is open source. They will never give you what's the data they're training from. So the more accurate name for them is a public available large language models. And when you have the public available large language models and you have your own dataset, or even the GPT-4, you have your own dataset, you have QA peers, you can still fine tuning them to get the large language model more fit into your domain. So this is large language models leaderboard. I think they definitely were changed recently. It's a long time ago. It's GPT-4 was kind of dominating at that time, but for now I think in the benchmark, the GPT-01 preview is kind of dominating it. But for the code experience and for our learning experience, the Cloudy definitely is much better than them. And for the open source world, there are some smaller models actually doing pretty good from the Microsoft. You can choose it later. So these are the recommended kind of models and in which scenario you should choose it. So for example, when we're trying to deliver this full-stack AI application, if you don't have any concerns about the privacy, then don't waste your time with the public available models because you still need some resources to run it or do something there. You just use the API from the GPT-4 or the Cloudy. And for notice, all of these large language models providers, they actually have the same endpoints. So you just need to use in your code, call the API from the GPT-4 and you get a result. If you think that they are not doing a great job, you actually can replace the model to another endpoints. It can be the Cloudy's endpoints. And later when they have the new models comes out, you can just use their new models. You don't really just waste your effort here to training a better model currently if you are focusing on just delivering values on the market. So if you don't have the data privacy issues, then use this one. Otherwise, if you do have the concerns about the data issues, like the medical area, then you need to think about the public available option. But this one means you need to host the large language model by yourself. You need to have a server or computer running somewhere waiting for other people to calling it. Then you probably need a dedicated team to do it. And do you have enough resources to get the response time as quicker as OpenAI? You probably don't, because behind the OpenAI you have 10,000s of the H100. You cannot compete in them, and it's not really worth enough to buy a H100 just for your own large language model. So that's the balance. If you must do it, then do it. The accuracy of the large language model, public available one, even the closed available one, is the model size increase, your performance will goes up. But people are working towards, research people are working towards getting the model size down, but the performance stays the same. So, but anyway, in the end of the day, currently for the public available model, you need to balance your accuracy, cost, and latency. It's pretty hard to balance these three. So if you don't want to waste your time there, then use OpenAI or the Cloudy to start this. And the large and the small recommended large language model are here. So you can try the Llama 3. It's the kind of best large one. But I don't think any of us in the Western Australia, or even probably in Australia, can run this model. We don't have that infrastructure support from anywhere from the government or from the school. So it's just to tell you we probably can do that, but we cannot. So your direction, if you want to do the open source one, then probably choose this one or this one. That's pretty good one. Or you can go to the benchmark to see whether there is better ones here. There is one actually from China, the Alibaba. There is called Quwen, which you can use that. That is also very good recently. So about the public available model I just said is there for all the public available model on the market nowadays, except the Google one and Twitter's one. The others, most of them are the variant of the Llama, which means they fit into the same license, is a Llama license. And the Llama license requested you if your user commercial is over 700 million users, you must request a license from the Meta. But I don't think we have that many people in Western Australia, so I'm not sure. You probably don't need to worry about that. And fine-tuning of the large language model, compared with the RAG, this is another direction, but we will quickly go through that as this is developer-focused bootcamp, not the research-focused. So Fine-tuning the large language model is another way get the large language model's answer more in context for you. So you will have your knowledge data come in, you train it based on your word knowledge, and you have a pre-trained model, which is the Llama or other models. Then you have your private data. Like we have some QA questions from the CS market, the CS volume. We can get that down. You have the question, you have the answer, you have the QA peers. Then you use some QLoRa, or you use just the endpoints from the OpenAI. You feed the data in, prepare the data in the format they require, and you can fine-tuning the large language model, which is adjust the weights of the large language model. In the end, it will show something like this. For example, this is the question from the peers area. If you have a pre-trained large language model, especially GPT-2, which is a smaller one, you basically will get some answer making no sense. But if you fine-tune it with large language, with medical knowledge, it will give you some in-context answers. And that's one of the directions. If you really want your large language model can have some general performance under your area, this is the direction you should you should look into. But this one, as we just said, this will require a lot of GPU resources. If you don't have that, then it's very hard. And but you still can fine-tune the closed source models, which is, I think I have an example here. This is the OpenAI's interface. All you need to do is prepare your model, your QA data, into the format they specify and upload it to here and select it. Or you don't really need to select anything here. You just click the create it, and then you can see something like this, and you just wait. You will get a fine-tuned model you can use later. So you basically, when you call the OpenAI, you just replace the model you call from the GPT-4o to the model you just fine-tune it. They have an ID here. That's it. So if you're looking into fine-tune a model and you don't have much resources from the GPU, you don't have the knowledge about this different fine-tuning technology, then you just use like OpenAI's one to start with. If you want to know more about this, there is one people in our group is recently actively working on that, is Kai. We were probably in the research here, like a bootcamp, we will have some introduction about this. So until now, we basically have the full understanding about what's the whole world have excited about the RAG and why they're excited about that, and what's the bottleneck of the problem and how you deliver it. But take a step back to now, we currently trying to deliver a full-stack AI solution to the end user. Then we need to think it about from the architecture perspective. So the whole process here in this RAG actually have two steps. They have two stages. First stage is called the data pre-process. You probably have a website, you have a list of the PDF files, or you have a database, something like that. And if you decided to use the embedding ways to do the retrieval, then you basically need to go through this pre-process. You get the embeddings, and then you get your a chunk, store it in a vector database. And then the second stage is data consume, which means you have a question, and you have a vector database already have all of the data installed out. Then you need to do the retrieval. So that's actually two separate things, right? We shouldn't get them put into the same file, which I have done that in the demo, because that's just a demo. That's definitely cannot be taken to the production. So this actually is why I spent this half an hour time to discuss what's the RAG and why we need to do the RAG and how we do the RAG, is cutting to this age. In our architecture, we need to split the data pre-process and the data consume. That's the key part. And about the Nanchain and Llama index, why they happen, I'm not sure whether you guys are familiar with this one, but it's pretty popular, and we give the demo yesterday. I think the Nanchain already have maybe 17,000 stars or more than that stars on the GitHub, so it's very popular. The purpose of these two actually is very simple. As a software engineer, you don't really want to repeat it yourself, so you can see there is a lot of general pipelines you can build, and You can just core a package and don't need to do the hard work just to reach the end of your goal. That's why they're trying to do. The founder for the Nanchain and the Llama Index, they come from the same company. And which is called robotic intelligence. This is the company do the security. And they find these two different entities in similar time. And nowadays they are all very popular in the world. But my recommendation, do we need them in your application? So you need to think about what do you really need in your large language model application rather than a traditional one, compared to the traditional full stack application. You must have a good vector database because that will change your latency about how long you need to take to retrieve the data from the database. But do you need a very complex framework to do all the pipeline processing? I don't think so. So that's a lesson I have learned, and also I keep seeing the same patterns. I actually have a friend doing a very popular open source project on the GitHub, and he spent probably 2 weeks because in the early stage of his application, he used a Nanchain to do the demonstration. And when it's going deeper and deeper, he's trying to build more and more customized solutions or try different combinations of the methodologies. He find out the Nanchain is the one stopping him going forward. So he spent 2 weeks getting rid of the Nanchain from his repo. So this one here, the big takeaway or big alert from me is my personal recommendation is do not use Nanchain and Llama Index in your application. If you have done that and in the early stage, get rid of it. It's not the way in the front for the applications for any full stack large language models. And the Llama Index actually already realized that. The Nanchain probably haven't. They realized that to somewhat. They're trying to get them as a module for the cloud operations. But for yourself to do the decisions, if you really want to bring your project to be a successful business, don't use that in the early stage. It's a very big lesson. So that's the RAG part. If you are interested with how should you to do the RAG with a website, we have a demo to do that. So this is totally use OpenAI stack. The embedding model is OpenAI. The vector store is also OpenAI. And our large language model is GPT-4o. And your input is a website URL. We will process, download all the text during the embedding. And the end user can ask the question based on the website context. This is a demonstration about what we have achieved. So the website we have put there is our NLP TLP group's website. And you can see this is annual result. The latency is pretty low. It's nearly production ready. So I have published the code here. If you want to borrow some idea, you can go there to check it. Another solution we have demonstrated here is a fully local solution, which means you don't need to use the OpenAI one. You just need to use, so the PDF processor is this open source one, and the embedding model is E5, which is a popular decent one. The vector database, I have written the code about the Contra and the ChromeDB. And the large language model in the local we have used is PHI-3. So the input is a collection of the PDF files. What you process is use this library to process them into text, split them into the chunks, and use the embedding model E5 process into the vector database and do the retrieval. So the answer of the question were based on the PDF content have been provided. So this is an example about this fully local solution. The code line for this actually is smaller. It's only 161 lines of the code for this one. It's also achieved is quite a performance compared to the OpenAI one because the model, large language model size is pretty small, so you don't really have similar performance as that one. But I also get the code being published here. So we have discussed so many about the RAG, how it's related to these full stack apps. That's the things we will talk about many today. So we have discussed this will be the simple one. Actually, a short one should be. We will see whether we have enough time. I can also do a demonstration. So for the full-stack application, in the very beginning of the 1990s, when the internet was starting, the website is just the HTML and the CSS. And then later, people were thinking we need to do some interactions. Then you have the Linux, Apache, MySQL, and PHP was dominating probably 10 years. But it's actually still dominating, just the people haven't realized that. The half size of the whole internet is built on top of the WordPress. So most of the website is still under this full stack. But it's just too simple for people to build that. And then from the 2010, you get the JavaScript revolution. You have this mean stack. This mean stack actually was being told when I was doing the MIT degree in UWA by Tim, I think. It's 8 years ago. But after that, the things also changed. Starting from the 2015, everything changed into the cloud. And you're starting to embrace the microservice. So you can see this is a 19 static website. At that stage, if you want to work as a full stack developer or something, you just need to know about HTML and some CSS, that's it. And afterwards, you get it to the WordPress stage. This is modern stage, like this is a WordPress framework for people to use. Currently, you still have lots of job titles for this, and it's taking the word still. And then the mean stack when it started, you can see from here is when the Netflix have started this kind of whole common things. It looks pretty weird because that's a stream company, but they're actually revoluting the whole like full stack area. And nowadays is natively people are introducing themselves as serverless. This is a training website that was built. I think this is a company starting from Adelaide, and it's an Australian local company. But they are currently the best teaching platform on the website across the world. It's called Cloud Group. All of their application actually is written in JavaScript and it's serverless. So when you're going to log in, it will call a Lambda function on the cloud, and there is no server anywhere. But the evolutions also affect us, which is a job title when you're trying to find a job. In the early stages, you can see if you have this kind of job titles dominating, webmaster, which just use a Dreamweaver to change your website, DBA, which is change the database like administrator, or you have a system admin to do the server architectures to make sure your server is running smoothly, deliver the content across the world. Then later you have this front-end developer, back-end developer, and you still have the DBA as a job title, but then you're starting to, in the modern stage, even nowadays, you're starting to see these titles: full stack developer. You're starting to see the DevOps engineer. You're starting to see the data engineer. Because other than the front end to deliver the values, the whole back end pipeline is becoming more and more complex. So the people to handling the back end on the cloud is getting more popular. That's why this DevOps engineer and data engineer for now is so many. I think in Perth, probably 70% of the job is about the data engineer. Even they haven't stated that in the job title as a data engineer. What they are doing in the data engineer is actually what we were doing in the data pipeline part, is convert the data format from one way into another, which is ETL. So that's the most dominating one. That's what we are teaching in the data warehousing. But I'm not sure whether people are realizing that. And then the DevOps engineer, the cloud engineer, they actually do the same thing. It's just their jobs focus is different, and how people was doing that is different. And same as a site reliability engineer, it's the same thing. Currently, Atlassian and GitLab was calling their DevOps engineer as SRE, and their offer probably is 200K. So that's kind of what is evolving. And going forward, what I'm seeing, I think years ago I sent a memo in the Discord channel, is what the people are actually looking for in current stages as a full stack AI engineer. They want you to know all of them. which is not really possible, but we're trying to get it possible. That's what the industry part. So as we said in the very beginning, this is for stack architecture we were like trying to achieve, and we were built towards. So the whole rack part explanation, what I'm doing there is trying to explain to you why we have this data pipeline and this vector DBs separation. So what this data pipeline will be doing under your application, if you are a RAG-based model or AI-based model, what it will do is you have your original data coming, and then your data will be processed by this module somewhere on the cloud or in your local or in a GPU instance, anywhere. And then the output of it will be stored into the database. And then when the front end is trying to do a query, it will send the query from here to here. So the query itself, the data consume process actually happen here. So that's why we designed an architecture like this. That's a pretty standard architecture we have done also previous in the company I worked with, is that AI company doing a heart disease detection. So we have internally, we have a research team who is in charge of this data pipeline module. And these data pipeline modules like basically fit into the job title. We have them as a machine learning engineer, or AI engineer, or data scientist. And their daily work is trying to get the model being updated to make sure their output of the data, of the result is accurate and ready to be used by the downstream platform. So when I was there, I was in charge of this part. I needed the whole architecture to get the middle layers of the whole platform into a scalable and responsible and modern format. And in the front end, then you have a front end team where query your backend and demonstrating all of the data in the front end. One of the challenging problems we are facing at that stage is the hard scan is actually very large. So every hard scan basically has 300 MB. And we wanted to load them to your computer, and you should be able to edit on the CT scans, edit the heart we have built, the 3D heart we have built. So, and then do the cascading calculation. So that's kind of the challenging part. So we need to have a very reliable architecture to handle that. And this is, that's actually similar to what I have delivered there. It's already been proven very efficient. The only difference is here, at that stage, we don't have this modern RAG or generative AI things comes off, so we don't really need a vector DB. We also don't need a graph DB. At that stage, I don't think anyone in Perth, except the research group here, actually know what the graph DB is. But nowadays, everything changed. These two become a core part of your application. So this is what we were trying to done in the end of this bootcamp, and that's what we started yesterday. So yesterday we said we have 3 repos. First repo is for this, what I have demonstrated yesterday is the front end. And then we have a data pipeline repo, which is the one I created at the very beginning as a package. And then you have the middle part with multiple services, which is your platform repo. So that's how we get them separated. So the justification of this tech stack, if you go to have an interview or something like that, you probably will be asked by your manager, so why you do this? What I just discussed is the justification. So why we need the data pre-processing there is because we need to get the data being processed. That's a totally different expert team should be in charge of it. But now we want you to also get that capability is because later you can find your job in that direction or another direction. But in a company, you will have a dedicated team to do this. So you don't really want all the things being overlapped with other people. For the database selection, the postgresql SQL is the most dominating one, or as an open source word. But if you are in the industry, you're probably using a SQL server. The content, this one is something I'm not sure about. That's what I tested, and that's the most reliable one currently on the market. The graph DB, you can choose different graph DB. Neo4j is something we're starting with, but that's no need to be the one you will be eventually survived in the end of this wave. We will need to still keep an eye on it. And the file state storage is like if you really process PDF files, then you will need to like have storage places to store the large files. And for the backend, why we use Django, not the Flask, not the Fast API, is because Django already have 24 years. And every functionality you think about, like you want to add on, it will have it. For example, Flask doesn't provide you an admin page, but the Django already provided you with that, which means you can directly interact with your database. You don't really spend time to do that. Django has a built-in authentication module. Flask don't have it. Flask have a package to do that, but that package is lack of the maintenance, rather than this one have a dedicated team to do that. So it's a natural one. Because we have a Python module, and it's pretty natural you will choose the Django as a backend framework. And it will be the trending in the future. The Azure is the one I was saying, like we were introduced later. This is the ones get you to just focus on delivering the values rather than writing the CRUD things in the backend. Which means you don't really need to write a REST endpoint. This one, what is provided is you give it a database and it will generate the endpoint for you. So in the front end, you can consume it easily. And for the front end, there are a lot of selections, but in Australia, the most popular one is the Next.js. In the big companies, you probably see them use the Angular, but for the Vue, is not that popular in Australia. Vue is pretty popular in China and Asia, but this one is we just trying to balance between the easy of usage and also like the market needs. So we will use this one. And different from the when the React first came out 10 years ago, the Next.js is much easier to be started with and used. So we will see whether we can fit it into 2 hours tutorial, and that will be delivered by holding not me. So we will see. And implementation plan, that's what we have said yesterday. I think all of you should already have these records set up if you have done the homework. Then about the deployment strategy, the module, the Python module, if you recall the medias like CUDA, we were plan to package it as a Docker with a media's Docker image, and then it can run on your local computer, or we can use some server somewhere to run it. But it will be shippable. For the platform one, we will also use a Docker to do but the development for the AI module will be native locally. You will need to create your own virtual environment in your local for the Python and do the development in your local, manage different Python versions together. That's the most challenging part actually for the development of the Python. We will touch base on that in next Monday. And the platform part is we will do it native development inside the Docker. So it won't be local development. And the deployment will also, we will do a trick. We just put everything in Docker and do the Docker compose up and get it deployed somewhere. But it's definitely not the production ready version. If you really wanted to scale up into the productive version, then you need to go to the cloud, for example, AWS, get it into the Fargate and open RDS, something connect to them. But we will start just using the Docker to get the 5 components in our platform running together. And for the React part, we will do the local development and we will deploy it to this a free hosted platform. So we will start to do some hands-ons, I think now, as we still have a lot of time. So first, you need to, because the front end is actually based on the JavaScript, you need to install these 3 things, which is Node.js, NVM, and Yarn. Is a package management. You don't really need to install the third one. NPM is also a very good one. But the installation step is first you need to install the NVM. This experience, the development experience of the Node is much better than the Python because they provided the Node version manager, which is why it's shortcut as NVM. And this NVM will get you have the capability to install different Node versions on your local and switch it just pretty smoothly. So you first need to install the NVM, and then there is a link here about the instruction. The next step, you need to install the load by this command. This means it will install the version node 18. And if you want to install this specific, I recommended package, then use the npm installer globally, the yarn. Then you basically get ready to what I have done yesterday, like get a Next.js to up and running. So I think that's basically all of the instructions of the description part of today. The homework today will be go back to if you haven't done the things we mentioned yesterday, go back to get that 3 repos set up. Get the front end repos set up with Next.js. And you don't need to worry about the Python package part. But we need to go back to get the AI for that with the platform part being set up probably with a Docker Compose file, which I will try to do a demonstration now, but I'm not sure whether I can because the computer is not mine. So, Matt, have you installed all of the things on your logo? Yeah. Okay, you have Docker, and I probably can just create a directory to do a try. Yeah. Then, yeah, I will try to do that. Yeah. So, we will make a 4-stack platform directory. That's the second module we will have, so the platform module. And we will cd to this one, and we will git initiate one. So inside, it's still a pretty old git. So that's one of the interesting. I think Matt have already set up the environment very properly, but this git probably is a bit old. Because nowadays, I think from 2018, they starting get the default branch of the git from the master to main, because master means master and slaves. So that's pretty funny history. And so the first goal we want to achieve is in this directory, we want to create a file called the Docker Compose YAML. And I think man haven't have the VS Code installed, but he have the PyCharm installed. I think you haven't get the GitHub Copilot being claimed, right? Yeah, go back to do that. Get a free license for the GitHub Copilot, and let's open this repo, and let's try to do some coding here. Because there is no AI here, then we probably, I'm not sure where I should start with. I probably should, do you have a GitHub? I think I have a, like the reason why I tell you guys to set up your development environment by yourself is basically for this reason, because you can see if I'm using another people's computer, you want to be able to familiar with it. But if you want to get yourself very efficient to do something, you need to set up yourself one very efficiently. I think I have one Docker Compose file examples. So yeah, this one here. So this autonomy is just a paper we just accepted. It's using the similar architecture we have used, we will introduce here. So you can see this is the Docker Compose file. It have a DB service. So we will use the way I was mentioning, just click the dot. You can check this repo in the GitHub. And we open this one. So this, you probably don't need to follow how I structured this repo, because this repo was trying to get the front end, back end, and the client module. This is a module, the Python packaging module I was mentioning, into one, but you can learn it from here. So this is the Docker, similar to the Docker Compose file we want to achieve. You have a database module container, which using the Postgre to SQL 13, which I think we will want to use PostGIS because some people probably wanted to use the GIS functionalities. If you want to build a map on top of it, then PostGIS is the only option on the website you can use. And you define the name. We don't really need to customize the Docker file by ourselves, so we just use the public one as this way. And you define your username of the database. You define your database name. You define your password. You mapping your ports together. The same thing happened for the Neo4j, but what I'm doing here actually is not a good basic practice. You should actually specifically the Neo4j's module here. It's easy to teach other people to follow the best practice rather than do it by your own, but that's how it works. So the environment variable was set up by them. So they, in their Docker files, will take this argument as parameters. So this environment variable will help you set up the Neo4j as like a username, and this is the password. And this is other settings you can follow. And I also declare the volumes here and 2 of the ports you can access them. This is the same, like you declare the volumes, and it's as we discussed, I think 2 days ago. This PostgreSQL data, this is Docker managed volume. So here are 2 databases in our this architecture. So this and this database already been declared here, so we just can use this part. And then what it has here also is API server, which is written in Django. So you basically can borrow the ideas from here. But we will try to start with copy this one here, and let's try to do a demonstration. If failed, I probably can give you guys a demo code somewhere, but we will try to get it to work now. So under this way, we declare a service with 2 of the database. Then what we want to do is we want to Docker compose up. We were first to evaluate whether these 2 databases up and running. So you will see it's trying to download the DB. So for now, we haven't changed this PostgreSQL into a PostGIS one. We will try to search for a PostGIS image. So PostGIS. This is the PostGIS public record. They have the text. It's very popular, as you can see. They have the 2 different versions. A lot of different versions, actually. This is 3 days ago. We probably use the latest one as a tag. So we use the 70 master. But you can change it to the 70 master later. We will see what happened here. So yeah, that's a pretty standard error you will happen. So I think now probably install a PostgreSQL database locally. So if you think this error, it means this port was recorded, which we already tell you guys in the Docker tutorial 2 days ago. So you just need to change the mapping, and then you do the Docker compose up. And do we have a database connection towards here? We don't. I think there is a plugin for you. So currently you can see the database. Okay. Currently you can see there is we have 2 servers and they should be up and running. We can use the Docker PS to confirm that. So you can see actually we have 3. One is the one I think okay, man was practice the NGX law years 24 hours ago. So you also seen that one, but there are another 2 was up and running. Is the 2 we have defined the PostgreSQL and the Neo4j one. They're up and running properly, so it means all good. And what we're trying to do next is we're trying to connect to the database to confirm what we are doing is correct. There are a lot of ways to connect to the database, but as you already using the JetBrains, then I will recommend this tool. You have this one? Okay, then it will be easier. So if you haven't installed this one, you can install this one. So it will be the same as other tools you will use to connect it to the database, but it's just a paid version with a lot of database connection capabilities. So what you can do here is you can say this is a full stack demo, man, and you need to give it the local host. And be careful, the port. So I think because our port in the host machine is changed, you need to change to others. And also the username here, you change the username. And the password here, you change the password. And also you have a database you want to connect to. Then you change the database. And you can test your connections. It's working, you apply, it's good. Then let's go check it. So you can see, okay, I have a database called this. It means all you have done actually is working. So it means our PostgreSQL database is up and running with the way we just described it. Then how we confirm the Neo4j, because that's another service we have done. So we actually open get a data port was being mapped. What's the port? I think that's the port number. So we can actually access it through this port. In theory. Why it's not working? Let's try another. Okay, this one working. So I just use the wrong port. So you can see here it's like you have the endpoint, it's were defaulted to the one. And you need to put the username and password. Where you find that? It is here. Neo4j and test the password. That's your username and password. You put the username, you put the password, and you click connect. It's in. So it means our database is empty, yes, but it means our database actually is connected. So you probably can do something here, but this is another way compared to install this Neo4j database in your local. You can use this way to get a graph database up and running. So we have done this too. Do we have a cloudy paid version I can use? If not, I can use the conjoint image. So we will need to introduce Docker for the conjoint. Like nobody actually know all the commands from the very beginning. It's very like a common. You should go to turn to the. Let's try. Do we have a cloudy paid version here? No. Free version? Also no. ChatGPT. I think ChatGPT should also be able to do the work, and we use the ChatGPT. Okay. So we're trying to do is we also want to bring up the conjoint as a vector database. So this is our Docker file. We ask it to add a service. Let's see what it will return. So you can see it's actually doing the same in a pretty good way. Right. Because I have done this before, I know what he is putting here is correct. I just cannot remember every single line of code. So it's pretty simple, you get them downloaded. And then you can Docker compose down, and then you Docker compose up. It's starting to pour the latest container of the conjoint down and spin up the server. So let's see what's the status of each container. So yeah, the conjoint one is also up and running. How can we confirm that it's working? So I think one of the things as a developer is you will always need to know what you're trying to achieve. and make sure you have you have ways, and you clearly know how can you make sure it's achieved. So for example, here we are trying to get a counter up and running, but currently accepted the programming ways to do the search, or use Python to do the search, or hit a specific URLs to do the things. You have no ways to be able to view it. So we know that if we can see something with this endpoint, because we just mapping the pods together, it means it's up and running. How to use it, we will talk about it later, or you can check their documentations about how to use it, and we also have the code examples about how to use it. But it's basically what we have done is we have the database layers, 3 services. Here, this, and this are up and running. So next thing we want to achieve is we will try to get the Azure also up and running. So this is the Azure we mentioned. So what they have like a branding here is nothing I care about. What we care about is their documents and what they can, like what I'm saying in the very beginning, what it means is can get your directly the endpoint. So you can see it from the product. What we want to do is connect to the PostgreSQL. This is what they're showing you. So you basically, after you connect to the database, you can directly do these queries in the front end, which means you don't need to write any backend codes. And what we're trying to do now is we're trying to have a container in our Docker Compose which hosted this Azure thing. Then how to do that? Like I probably, if I have the same status as you, I don't know how to do that. Then I should ask the GPT or the cloud to do the same thing. So add Azure as another service in this Docker Compose file. That's what I will do actually. So you know what you are trying to do in this step, right? Just add one more service into the whole application, and you can see, let's see where it's doing the correct work. Yeah, it's actually doing the correct work. So we can copy this, we can paste it here, and we do the same thing as we doing last time. We need to stop the containers, so we need to Docker Compose down. And we do the Docker Compose up again. You can see it's starting to download in Azure. So you can see it's pulling up. That's what I mean in the Tuesday when you're trying to using the Docker. The first is we'll check whether you already have that database running locally. If not, it will. This is wrong. So you can see actually it's wrong here because it says the variables of the GW secret is invalid. Key size too small, at least 23 characters. So which means this key size is too small. So another thing developers must to like learn or very important capability you should have is learn read the error message. Make sure you understand it and change your code accordingly. So I just add some random things there and trying to get it up. And also, I think it's already pretty smart. This is the one as what we are doing in the very beginning in the data groups. We're trying to connect to the database. This is similar as what we are doing there. So you will get it endpoints of the database, so the Azure container can connect to. So what you put there is you can see username, password. The DB is what we say in the Tuesday, the Docker's data work. So the DB is the host name actually. So it uses the DB here. And because this whole Docker Compose file actually created one network, which is a virtual network for itself. So we can check it here. So Docker AirS, you can see there is a network specifically for this Docker Compose file. Means this service, and this service, they're all in the same network. That word means here is 5432, not a 5433, because this service we're running as Azure is also in this network. So for them, the door of the room is 5432. So So that's kind of, in the practice, you're starting to understand what it means in the Docker data work concepts. But until now, you can see the Azure is also up and running. So what we will do is how we confirm that. That's the same step we going before us. So localhost 8080 as the endpoint we just mentioned. And it's asked you to put it in an admin secretary where it is. Like that's the normally question asked about the questions, but if you go to the Docker compose file, it's actually here, everything documented in the code. So that's the admin secretary you should put in. So you click it, remember it, you go in. So you are in, and you connected to the database already, but we don't have anything in the database. So what I want to be able to show any powerful things here for it, but we will show you the data. Until now, we have, let's go back to our diagram again. So we have 1, 2, 3, 4, all of the 5 servers up and running. The local desk one is actually the folder size of the volume, so we don't really need to worry about currently. So we have one last things we haven't included in the service, which is the Django. This is actually not that easy now. So currently in our repo, we only have a file. We needed to actually create a Django project and mapping it to the Docker container. So summarize that is, we wanted to create a Django project, and then we copy the code as we said in the Tuesday's like Docker's tutorial. We want to copy and mapping the code in your local together with the volume inside of the Docker. So when you change the code locally, your environment inside the Docker can do the coding things. So you can be able to like a coding and your virtual environment is running in the Docker. I cannot edit this. Sorry. Okay, it's still okay. So then the goal is currently, as I said, is I needed to create a Django project and logo. Let's see, do we have a Django logo? We don't. So that becomes an egg and like a chicken things. Let's ask the ChatGPT where they do it. Like if it was me, what I will do is I will install the Django's package locally and initiate the project like what I'm doing for the Next.js. And then I will set up a Docker file. And inside the Docker file, I will say you need to install all the requirement packages. And then you basically being able to have the Docker environment set up. Then when other people pour down your code in their local, they want to be able to lead to do the same thing as you, like a Docker, use a Django initiate project in your local again. They just need to Docker compose up and everything works. But here is like I will trying to see what ChatGPT can do. If not, I will do it my way. And because I think man doesn't have Cloudy, actually Cloudy can be much better. So it is much worse to get that done. Let's see what he is doing. So, and even I say that like the ChatGPT is not as good as Cloudy. What we have seen here is until now, what the GPT provided just have one error. So it's already very amazing. Okay, it's actually provided a pretty comprehensive instructions. But the problem is we don't have that Django directory in our local. So you probably will ask the question how you initialize one, as you don't have one in the local. What it will do. It's probably will fail this time. That's the part, it's not as good as Cloudy. Oh. Okay. It's actually pretty smart. It's potentially will work, but that's not the best solution. We will try this way to see what's the error, and we will debug from that. It's starting pulling, because it's give the image of the Python as a basic requirements, it's starting to pulling that down. And we also have the same problems with Azure. You can see that you need to tell it to fix the problem anyway. Let's see whether the Django is started properly. No, it's not. And it haven't, it's supposed to be it's created a Django directory. Yeah, it's not doing the correct things. So it's failed this time. We go revert back to our last version. So we will do it in my way. So that's actually another part of what I'm trying to demonstrate here is you can use ChatGPT and the large neural models to help you. But we have a trick here is like if you don't really know what you are doing, then you probably will spend ages trying to do the debug problem. So if it's for example, he dumped the code for me, I know what it's trying to do. It's trying to use a Python and then run this Django admin command to start a project. First created all of the Django project files, and then later to doing this like a proper setup. But if you don't really know what it is trying to do, then you don't really have been able to do the justification whether it is doing the correct things or not. So always in a high level, understand what you're trying to do here. Don't just copy their code and run it. That's bad practice. So we were given another prompt is we wanted to initiate a Django project locally. That's actually what we want to achieve. So we will see what it's trying to do. It will give the Django version, and it will want to create a virtual environment. Then we will follow its instruction, and probably not this way because it should be inside of the Django. Anyway, we create a virtual environment, and we need to activate the virtual environment of the Python, and then it's give the command how you start. You need to do the packet install. So you do the I probably go here. In that terminal, they have some problems in sharing. So I go there. I need to activate the environment again because it's another terminal, and then being activated. And I need to install the Django. It's being you already installed it. That's weird. And then you want to start your project in here. So you have the Django admin start project. You give it a name. So my one probably is full stack demo. And you can see from the projects here, it's actually created all the things you need for a Django project. But it's actually not in the proper folder I want. So I need to move it out. And this is asking whether you add it to the Git things. We will cancel it here first and do it later because we haven't set up the proper things. And because of this reason, our virtual environment also have a problem. And we don't really need a virtual environment later. So we will delete them. And then we will need we have a Django, and we will try to get it running locally first to make sure that we know what we are doing, and then we Dockerize it. So we are inside it, and we should deactivate it because it's not yet a virtual environment. So we will reinitialize the virtual environment. and trying to do the Python install Django. And then you can try to run server. This is the command you can start the Django. But you can see there is an error here. It's asking you to first run the migration. So there are some commands you will need to remember and understand later in this whole process. So you need to first run the migration. Migration is you have the database changes. You need to apply all the database changes to the database. So after you run the migration command and you run the server, you'll be able to access this local host 800. And this is Django up and running. And next is we trying to Dockerize the Django. Dockerize Django means we want to add a service here, which is called Django. Or you can call it the API. And this time we need to build from our local. So we have build, and we have context, which is dot, no, not a dot, which is a 4-stack demo, and image. I think we have image. I don't remember, but we can put it there and give the instruction there. This time you probably will do later because I already do the hard part work for it. So for now, it's actually simple work for it. So you just need to add another service in your Docker Compose file. So I have already get a Django project in my local 4-stack demo folder. I want to include that as a Docker Compose service. And you needed to return me a new service in the Docker Compose file I provided above. And also give me a doc file, because this time it's a service built by yourself. And let's see what it can do. But before this large language model ages, what we are trying to do here, just not asking this question, what we're trying to do before is search through the Google. We have a Stack Overflow. And what we are doing is just to go to the Stack Overflow, copy some code from other places, or copy the code from your previous project and put it locally, get it up running. The large language model comes, I think our daily work actually also been changed by this, because this will be my common ways to do my work, is doing something like this. So let's see whether it's working. So it's trying to copy it. And then it's also from my instruction creating a Docker file. And this Docker file, we should put it I think this ID doesn't respond because of the Windows, but we will try to do it in the order efficiently. So I have a Docker file here, and then I will do the Docker Compose down and restart it to do the Docker Compose up to see whether we get the backend up and running. But we can read it there. Let's get it up and running first, and then we can see what it is trying to do. So it's starting to build the Python, and it's one of the requirements, TXT, which we don't have there. So we will create one. Requirement TXT is the one we manage your Python's packages dependency, if you don't know that. And for now, we add it, and we have it, then we redo it. You see. Okay. Let's see whether the Docker is up and running. Django, yeah, Django is up and running. So let's see this time the local host 800 is up and running. So here in this whole architecture, we do the Next.js part yesterday. So if you haven't done, like install the things we have mentioned, the NVM part here, I think here, and get the Next.js installed, get that one up and running, and set up the repos properly. So if you don't know how to do it, we also do a demonstration yesterday in the video. You can reference there. Currently, what we are doing is we get this as a database bearer service in the Docker Compose file. We have Azure been set up properly already, connected to the database properly. So we can do something there. And the rest, the Django service, we also get it up and running. So the whole platform part of file service is all up and running. We basically reached our goal to get the platform up and running. And at this stage, because I get the Django up and running, no, but I haven't configured the database properly, so I won't be able to show you. I can do the configuration with the database. So here, Django's default database actually is a SQLite. So you can see here, and you're supposed to see your database here. But for us, we don't want this to be the database. So we need to connect it to our database we just created. That's another question you want to ask ChatGPT then is, I wanted to change the Django DB to the PostgreSQL I created. How to update the Django thing, which is this one here. Then there are a lot of good ways to do it, but I just want to start with a simple one to do a demo. And that's exactly what is returned to me. So I can just copy it, and I replace this section. And hopefully it can run, but it cannot, because you can see that's the IDE part good. So you can see this OS things, it won't work. It says like you don't have that package, so it's not defining the Django was failed. Then we need to redo it. Docker Compose up. It says we don't have this Python PostgreSQL module, which is valid because we need to install a specific package to get the PostgreSQL to up and running. So it's actually already tell us that. So which means we should put this one in the requirements. And then we should go back to say Docker Compose because it's in the requirements and the requirement installation is in the build process. So we need to add a minus build to reinstall this one. And hopefully in this time, where is the Django? So we cannot see the logs of the Django as I said last Tuesday. What we can do is we find the Django's code. It seems starting properly, but why is waiting the file changes? It's weird. Let's see what's the command it's put in the Docker file. Let's see whether the local host is accessible. Okay, it's accessible action. So, but the problem is here, we actually haven't run the migration of the database we have shown you before this. So you can see you probably want to go to the Django server. No, this one. And the bash. So that's basically the reason why I want to get everyone was understanding the practice all of the code in the Monday or in the Tuesday about how the Docker was working. So now we go inside it and we want to run the migration, and it's running the migration. It means the database changes was being applied. How you check that? You can check it in two ways. We have the database. You can refresh it. You can see you have the table being created. These are the data tables created by the Django. So you can see, and the migration is the table actually manage the migration, apply the status. So you can see all of them action is being applied that you can connect to there. Tables are created. And then what's the beauty of this tour of the Azure is you can see the table just created are being seen here. And as a backend, you wanted to create the API. Before was you need to write a lot of CRUD things, which is query and update or retrieval. What you need to do is basically you click this track here, and then it will give you the GraphQL interface already, so you can query from the database. So everything, like what I have just done, 2 steps, I click it twice. One is track, and then I come here, I already can query it. And that's all. That's all the backend already up and running. And later you can integrate this as Apollo's GraphQL library and put it at the query. It will be able to go to the backend to do the query. And at the same time, you can do the mutation and you can do the subexpression. Subexpression means your application can real-time be updated because if the backend database have any updates. So how it works is in the database, they have a trigger. So any changes in the database, it will trigger an action somewhere and you'll be able to use a WebSocket to push the changes to the front end. Originally, with without this kind of tools, we need to spend a lot of time to write a core pipeline. But for now, you get an out-of-box functionality with these tools. So until now, we basically have a demonstration also about what we want to achieve today. We have this platform part up and running. So today's homework basically is go back, doing what I just demonstrated to get your platform part up and running and be able to connect it to the database and connect it to, we have 2 people in the lobby, sorry. So be able to connect to the database and see what I just seen and trying to interact with these 5 different services in different ways. That's what we want to achieve today. So it's a pretty long demonstration and it's a new computer for me, so it's really lucky we haven't, with the help of the large language model, we haven't have any accident. But that's kind of also demonstrating how can the AI help you to do the programming, like even if you are pretty the new entry level people in this area. So any questions today? Online? Yeah. Yeah, I think what I just seen from man's computer is he definitely practiced a lot. So I think that's a very good sign. You're actually doing the correct thing. And I don't really actually the documents I put there in the development environment setup is from our company. Our onboarding section, I take that out and building these things. when I was doing that, it's actually also spent me quite a fair time, like to get that community. So I think men are already doing very good. I think the same thing are happening with others, hopefully. Okay. Yeah. Any other questions? If not, we will wrap up today. I think today's homework will be a bit challenging for most people. So, yeah, get a use with ChatGPT and Claude. As you can see just now, I haven't copied from somewhere else except ChatGPT. So I think you can do the same thing. Try to use the Claude and the GPT help you to get that done. And if you cannot, just ask a question in the Discord server. Ask me how to get it done. It's pretty straightforward. And man, you need to do it by yourself, even the code is in your computer, okay? Okay, that's it for today. I will stop the recording, and if there's no questions, then thank you guys. See you all. See you. Bye. Okay, Peter, how much do you have now in your computer?
Stack Docker in the boundary setup.
Okay, yeah, that's very good enough. Yeah, practice on Docker command.
Yeah.
That's very useful. Hello.
Hey,
你好，
possible. Yes.
你好，跟我说过。
我们是写的在微看是公开分。
没事儿，有什么问题问吧。
我是想咱们就你刚刚做的这个部署，这些 choices of databases, what kind of use case are we focusing or targeting to have these kind of choices of databases like vector graph databases?
General graph application.
Generally.
It should be applicable for any AI solution, graph based.
Sure. So Victor actually mentioned something where we can demonstrate how our graph writers actually being done at the moment.
Yeah.
And you said it's completely wrong, it's the past.
Yeah, like the graph dragons demonstrated by the Microsoft is just an easy win for the paper. It's not what's the graph drag actually in
So
most of
in
people's.
your conception or in your application, how the graphs of any knowledge being ingested into the graph database, and how are these being resolutely the identity have been resolutely connected as nodes.
That's a sorry. I'll close that like my phone first.
Okay.
That's a very actually